Hello, Year 6. Today I'm going to attempt to teach you how to use a protractor without actually showing you. So let's go through a PowerPoint which explains it really well, and then I will show you a really good website on which you can have a go yourself, especially if you don't have a printer or a protractor to use at home. So you'll be familiar with what a protractor looks like. This is the general shape. Sometimes you get them in a complete circle, but the ones we have at school are these half circle ones, which we know to be a semicircle, and they go from 0 all the way up to 180 degrees, both ways, 0 all the way up to 180. So we'll have a little look at how to use one now, and then we'll have a play around. So the first thing you want to do is when you have an angle, let's look at this angle in particular here. If you have an angle, you want to measure how far open the angle is. So you always measure at the vertex, at the point or the corner, as you might know it. So you always put that right in the centre at the bottom of your angle measurer of your protractor. There will be a cross or a little circle, and that vertex has to be right in the middle. You then need to line up your angle measurer or your protractor along with the zeros. This bottom line here, you want a nice straight line from that vertex, that centre point there, all the way along to 0. And then you're going to be having a look at the space between 0 and where the other line crosses the protractor. So in this case, you can see that the bottom line starts at 0 and it finishes at 100. So it goes past the 90 and it's 100. So this angle, this measurement of this angle here is 100 degrees. So it says here, again, just to reiterate, from the 0 on the outer scale, so always going up from 0. Don't go from 180 all the way over to 80 because that won't be the right measurement. We're starting from the 0 and we follow the scale up to 100. So it says here, if you have an angle that is between, say, 10 and 20, you need to count the lines very carefully. So much like on a ruler, where you would count the millimetres between the centimetres, in this case here, if you look at 10, you can see that there are 10. If the line was here, it would be 11, 12, 13, 14, 15, so that midway point between the 10 and the 20 is 15 degrees. So each little mark here is worth 1 degree. So we can see that this angle here, it's an acute angle, we'll get onto that later, is just 20 degrees. Imagine if you'd measured it at that 180, you said this was 160 degrees, that would be wrong. But the measurement of this angle here, so that means that the vertex is right in the middle of the protractor. You can see that this particular angle is 20 degrees. So if you are measuring in an anti-clockwise direction, this is where you use the other scale on your protractor. So once again, it's so important that we start from 0. So we can see here, right in the middle, the vertex is lined up beautifully in the middle of the protractor at the bottom. As I said, this could be a small circle or it could be a cross. The vertex must go in the middle of there. You then make sure that the bottom line is in line with the 0, so you've got a nice straight line at the bottom, not beneath, not above, but on it. Then you count from 0 up to the measurement where the line crosses the protractor again. And we can see here that this measurement is 50 degrees, from the 0 up to the 50. It's not 130, that's the wrong scale. That would be measuring it from 180. So we're going from 0 up to 50 degrees. So it's a really good idea to try and estimate the angle before measuring. So I'm going to talk to you in a moment about the different types of angle that you come across in Year 6 and going into Year 7. So just to reiterate, have a cross, put the cross or the circle at the point, so the corner, the vertex, then read from 0. It doesn't matter which side of the protractor you're using, just look very closely for the 0 and follow the scale around from 0. Make sure that you count the degree lines carefully. Each little line is 1 degree. And you might need to just check on which scale of your protractor you're using. So let's have a look at these shapes then. A triangle made up of 3 vertices, 3 corners, and you can see the angles here. This is actually an equilateral triangle because you can see that each of the angles is approximately the same because the lines of the triangle are approximately the same. But if you have a look at the angles A, B and C, if you measured them all, each angle would be the same. However, when we add them up together, they will make up to 180 degrees, which is the same as the angles on a straight line. So if you drew a straight line and you used your protractor to measure it, the straight line would measure 180 degrees, and that is the same as a triangle. It doesn't matter what kind of triangle you're working with, whether it be a right angle triangle, a scalene, an isosceles, all angles in a triangle add up to 180 degrees, which is the same as a straight line. When working with a quadrilateral, again, it doesn't matter what quadrilateral you're working with, a shape with 4 sides will always add up to 360 degrees. And you can see here in this diagram that each of the vertices has been given a label, A, B, C and D, and those angles have been placed together in this diagram here, and you can clearly see that they make a circle. So each of the angles in this quadrilateral, they all add up together to make 360 degrees, and that will be the same, as you can see, as a circle. So a triangle and a straight line all add up to 180. A quadrilateral and a circle also adds up to 360 degrees. You can think about it if you know how to use compasses, or if you're turning around in a full circle, a 360. If you know that a half pipe, if you're skating, is 180. So we're thinking about how we are measuring an angle. So I think that's it for the shapes. A little bit of an extension here for some of you who might want to know a bit more. We're thinking about how we can work out angles that are opposite, interior, exterior. Something that's interesting about angles is that where you have opposite angles, they are always the same size. So if we just have a look at this diagram here, the vertically opposite angles on this shape here. So if we just look at the black lines, these 2 lines here are parallel, which means they run alongside each other and never meet. And we can tell that because it's got this little arrow shape on it. And this line has crossed through those parallel lines. If we were working out the angle of A, then we know that the angle A would be the same as angle D. The opposite angle would be exactly the same measurement. Likewise for B and C. And we know that altogether those angles would add up to 360 degrees. So if we knew that angle A was, say, 40 degrees, then we would be able to work out that angle D would be 40 degrees, giving us a total of 80. So we would be able to work out B and C by taking 80 away from 360 and dividing it by 2. If we have a look at the alternate angles diagram here, we can see that C and D angles must add up to 180 degrees, because they go along this straight line here. But we can see that the alternate angles here, C and F, would be of the same size and therefore the same value, as would D and E, the same size, the same angle. If we look at corresponding angles here, we've got basically a circle that's been drawn around these parallel lines that have been crossed through here, and you can see that the corresponding angles, so the angles that are repeated, so we've got angle A is the same as E, so you can see this angle here is of the same size as this here. B would be the same as F, H would be the same as D, and C would be the same as G. And likewise here for the interior angles. If we can look at the picture as a whole, and if you can start looking at shortcuts where you can see what value one angle is, you can compare it to another. So that all sounds quite complicated, and so I'm going to show you how we can start playing around with this. So I'm going to come out of this screen and I'm going to go onto this website here. This is mathsframe.co.uk, and this is going to be particularly useful for you if you don't have a protractor at home and if you don't have a printer from which to print the worksheets. So we can set you some work that you can do on this particular program. So this is really clever because you can create your own angles. So I've just clicked on this A here. So this is going to give us our vertices of a particular shape. Let's make an angle like this, A, B, C. So then I'm going to get my protractor. Just press this protractor button here. This blue thing moves it around like this, and you can just click on it and you can move it up and down. So I know I need to place my protractor on the vertex, which is at B, so that is the corner. And I need to place that middle line, that centre line, right on that vertex there. And now using this blue dot here, I can move my protractor so that it is completely on the 0. On a real protractor, you actually have an extra bit of plastic along the bottom. But here I've placed it right in the corner as far as I can. Maybe it could go a bit further down of this vertex here. And then I can measure my angle. So going from 0, it's not 10, 20, 30, 40, 50. It's almost 60 degrees. I'd say that's about 59.5 degrees if I'm going to be a bit picky about this. And I can try this with a variety of angles. So I'm going to explain this in a separate video again, looking at different types of angles so that it's more straightforward for some of you.